Let's get the show on the road. All right, guys, how's it going? Good to see all of you. It's been a while for some of us.
Introduce yourself?
Yeah.
That was good.
I'm a new hire here. No, my name's Garrett Kozat. I'm a project engineer here. I'm working on the Uncommon in Flagstaff, Arizona.
I'm Leanne. I'm working on the One North project in Kansas City.
So we may or may not be uniquely qualified at this specific point in time to give a training on wood framing. I'm working on a panelized project with the Uncommon team down at Flagstaff. Steve Bot, 6 to PM, and Lori Badalamenti is my counterpart, and then we've got Jason Mayer and Jeff Schwetman working down there as well. We're probably right at the midway, or just a little bit past the halfway mark with our panelized wood project down there.
Yeah, so I'm doing stick framed. Our project is wrapping up right now, so we got about 2 weeks till our TCO, so exciting time. But we got Brett Krassinger, who's not here right now, but he's our project manager, and then Bobby Stoessel. He's done a lot of hotels. Little background on our project: it's 2 different hotels. So there's an Aloft hotel, an Element hotel, and then a conference center in the middle. So some of our phasing, we'll get into that on how we did that, but.
Yeah, so we just wanted to give you a little bit of introduction about who we are to prove to you that we are actually somewhat qualified to be giving this training to you. So just to kind of go through the overview. So we gave you our introduction. We're going to tie pre-construction to the field operation aspect of it, because our presentations today are going to give you a heavy focus on what it's like to do the day-to-day on the job site, things to look for, and what all goes into that. But there's a lot with pre-con that you have to think about when you're thinking about field ops. We're going to hit on scheduling and planning. We're going to talk about the site and project logistics. We're going to touch on field QA and QC pretty heavily, and then we've got some coordination and details that we want to touch on, and then we'll wrap it up and open up the floor to any questions that you guys might have. So the goal of today's presentation is hopefully when we leave today, you guys have a little bit of a better understanding of what it's like to be on a stick-built or panelized wood project if you've never been on one. Hopefully if you have been, you're able to contribute a little bit, or you learn something maybe a little bit different, a little bit new. The way we're going to structure our presentation, so Leanne's going to focus on giving you guys some information. It's more focused on the stick-built side, and I'm going to focus more on giving you guys information that comes from a panelized perspective. So we'll kind of be, ping-ponging back and forth between each other, switching back and forth, trying to kind of help tie it all together. And then obviously, open format, you guys have been bringing the trainings before. Make sure if you've got any questions to ask them. There's probably, if Leanne or I aren't able to answer the question, I'm sure there's somebody in the room that's going to be able to provide a little bit of insight. And then, we're here to answer your questions. So if you have anything that you want to know or bounce off, we can let us know, and we can do some more research, after the training. So let's jump into the pre-construction items here. So I sat down with Matt Funk for a little bit this morning and kind of ran through, picked his brain a little bit about it. So as you guys know, and this probably goes for every single project you're ever on, a lot of decisions that get made during the pre-construction phase dictate how your field operations are going to go throughout the duration of the project. So when you're talking about wood projects, for example, the decision to go stick-built or panelized, that's going to completely take you down 2 separate paths that have 2 separate game plans, 2 separate schedules, 2 separate everything. So we wanted to touch on that because a lot of, even though pre-con isn't a really field operations type thing and it's really separate, that decision, that thought process that goes in early on will drive how the team makes their decisions from basically the handoff to completion. So what drives the decision to go stick-built versus panelized? In talking with Matt, it really depends on markets. For example, in the St. Louis area, stick-built is a little bit rarer than if you're outside, and the unions drive that because stick-built is probably 99% field labor. You're doing all the work on site, so that means you got union carpenters throwing it up. Union labor is typically more expensive. So stick-built in a union market, people try and stay away from that in order to avoid the costs that come with it. But panelized, the decision to go panelized, it sounds like for most of what everybody's working on, I'd say a majority of the projects that Brinkman's working on now, it's a panelized project. And the reason that is one, if you're in a union market, you've got more shop labor, which is cheaper. But two, a lot of times schedules will drive that. And a lot of times the way that you're able to sequence your job, you can get a panelized project, assuming you get all your ducks in a row early on, you can get that schedule to flow quickly and you can get projects completed in a fairly fast manner. And like I said, schedule can really drive that decision. Another really important thing you have to know way up front, and I think you've got cranes on stick-built jobs, but you definitely have cranes on panelized projects, but understanding from a brakeman perspective, is brakeman going to be the one that buys the crane, gets the operators, and coordinates all that, or are we going to make that a subcontractor responsibility? Because that's usually a really large sum of money, and knowing who's going to be responsible for that component of the work is imperative to know from the get-go and get it all coordinated and lined out.
So on top of crane, what does everybody think about first time somebody mentioned panelize a project? What's the red flag that goes up for first thought? Anybody?
Shop drawing page.
Shop drawing, which comes along with that? What comes along with that?
Everything but that.
Everything bought out.
Yep.
That's the first thing. Especially if you're doing, I'm sorry, I'm probably stealing your thunder.
No, it's fine.
Especially if you're doing design, build, MEP. I mean, you got to get on it quick. So when you start going panelizing, if you're not in front of the curve, man, you'll be behind up. And I've been there. You know, we're a lot better at it now. We first were panelizing things 15, 20 years ago. I don't think we had it figured out as well. And it's tough. And being a project engineer on a job like that is no fun. So if you got it all figured out, knows every possible opening size and everything else for your panels, it goes pretty smooth. But if you, the manager, don't have it bought out, you never catch up. So.
No, it's really good. We do get them out, but
It's the first thoughts come to mind.
yeah, for sure.
So on the just kind of to go over this, we already touched on that last week, but the submittals basically will look pretty similar as far as stick build and the panelized projects, but the one thing that they most differ on, which we just talked about, is the shop drawing phase of all the panelized shop drawings. So one thing that I did, since we didn't have, I think when you go through all those panelized shop drawings, just from looking at everyone else's, that you really understand the drawings well, and you see where your MEPs will overlap into everything. So one thing that I tried to do on our project specifically was on our layout drawings, trying to put all of where our mechanical like ducts were going to go through all the trusses and everything, which we'll look at a little bit later. But that was probably the biggest thing for the stick built from the panelized shop drawings. That's a little bit different. And then another big thing that we need to look at is always your weather barrier information, to make sure that you have a zip and tieback rep involved in the whole process. So you want to make sure that they come out and do a few site visits. They're meeting with everyone on site, your superintendent, your engineer. Specifically, they need to meet with your framer, make sure they understand the requirements. And it's not that they're going to be going through the architect, but they need to make sure that they apply to the requirements through the zip system or tieback. And then other things to just check for when you're in the pre-construction phase before anything has really been put into place, but just making sure that all your doors, it sounds like silly, but making sure that all your door swings and everything doesn't conflict with any FF&E or casework. And then like your barn doors. So those, a lot of them are different depending on what you have, different clearances above that. So if you have really high ceilings and your barn doors are really big, that you need to make sure your rough opening doesn't conflict with the hardware that you have, and make sure that your door comes above that rough opening. And then another thing just to double check is your stair run lengths with your landings and tread heights and your stair shafts.
Hey, Garrett, before we dive into the scheduling stuff, I mean, I guess from us doing panelization, it also, in my mind, if your drawings are incomplete or just not great, I think a panelization, you're pretty much hiring an expert detailer to check the structural engineer, and you can flush out a lot of the RFIs and a lot of the potential conflicts before it actually snowballs onto a field delay or an issue in the field. So I know our project, for instance, we're light years ahead of where we would have been if we were trying to stick frame this and the RFIs were coming up as the header didn't work as we came across it. So, I mean, I guess that's something to at least take into account, is if you have concerns with how complete your drawings are, how great they are, a panelizer would be a good option because that'd be somebody that really kind of flush out all the drawings and make sure it works.
And I guess to that point too, like when you're panelizing, our panelizer designer, they're a subcontractor just like any other sub. You can find good ones and you can have bad ones. We looked at and we had a really thorough good one. So keep that in mind if you're panelizing, because if you have a less than great designer and they're just taking what's in the drawings and making panel shops out of it rather than like thinking it through and coordinating with everything, that could almost cause you more headaches down the road than if not. So that's a really good point, because not only do you have another subcontractor, but they could also be good and bad. So. Well, jumping into kind of the scheduling and planning phase after you roll out of that pre-con situation. So kicking off that subcontractor design process and understanding all the items that go into it. So like Kendrick was saying, having your MEPs mostly designed when you start getting into that shop drawing process with your panels is so, so important. I'm not saying they have to be 100%, but if you could set a priority, like in your early MEP design meetings, if you tell these MEPs, look, the things that we got to have from you guys first are any of your penetrations from floor to floor, shaft locations, any place where you need some additional wood framing for, RTU support or any other mechanical, electrical, plumbing, any other types of equipment, get those things sorted out first. We can connect the dots, we can connect drains later, but we need to know shafts and knowing what those critical MEP related items are so you can get that shop drawing process going is key in making sure that that ball starts rolling and keeps rolling with that panelized process. Outside of MEPs, there's still other things. Rough openings. Any rough openings you have, doorways, windows, your architectural dimensions and things like that. FHA, ADA, all that stuff's got to be figured out in order for you to go. And Steve, me and Leanne were talking, and we were thinking, does anybody out here, know if there exists a checklist of things to have compiled before you can go to a shop drawing process? Do we have anything like that? Is that something we should put on a Brinkman, somebody champion to put together like what do you got to have before you go to panel process kind of thing so that you have a checklist you can go through? And I mean, that was something we came up with just today. We're like, wouldn't be a terrible thing to have.
In the presentation we had last week, I went through and made a pretty thorough checklist. It had probably 25 items on it.
So that'd be a sweet thing to have as like a company-wide document.
Yeah.
Outside of the training.
Especially someone who gets thrown into a panelized project who has never done it before. That's something you could always go back to, because when I started it, I had no idea what to do.
Yeah.
Eisen has one that they send. It's their RFI number 1 that is generally pretty thorough as to what they need before they get started.
Okay.
I guess the caveat to that too, though, is let's not get hung up on checking all those boxes before seeing those drawings get started.
We should probably, you could probably prioritize out of those things what are must-haves and what are not so important.
Right.
But, okay. Well, I might shoot out an email afterwards then, and we can try and compile information between the training last week and what Isaac's got, throw something together in the next few weeks. But, okay, and then another really critical thing, depending on your project, like most wood framing projects, whether you're panelized or stick built, you're going to have gypcrete involved with your project somehow, some way. So understanding how much of a depth, whether it's, the minimum 7/8 like what we have in Uncommon, or if you have 1.5 inch or greater than that with the sound mat and all those kinds of things. So knowing what that is, because that's gonna cause your door frame heights on concrete. It's not gonna affect it, but when your door frame heights, and you have to take that depth into account when you're doing all your panel designs. So keeping the ball rolling on the scheduling and planning side of things, what I wanted to do, so this is a little bit of a case study. I've got a lot of examples from Uncommon down in Flagstaff, but to give you guys kind of an idea about how fast panelization can go. And it sounds like stick built can keep up in some instances, but this is a picture of this project on May 24th of this year. So we had just stood the first panels on our 3rd floor of our first phase. Roughly 3 weeks later, it's about 3 weeks to the day, 15 working days, we were setting our first wall panels on the 4th floor above. So we were able to knock out exterior wall panels, interior wall panels, the floor trusses for the floor above, floor sheathing, all the associated inspections with that, and then get the panel started in about 15 working days. They were working weekends and things like that, but if you look at a work time frame, they're cranking out a floor of about 20,000 square feet in about 15 working days. That being said,
It's kind of the magic number, the 20,000 square foot in about 2 to 3 weeks, whether it's wood or metal and concrete. I mean, that's kind of the magic number for Verizon, and they use concrete instead of gypcrete. So
yeah,
if you're ballparking 20,000 square feet with a footprint or a floor plate, then 15 days is about accurate to get to that next level.
sure. Well, to zero in on it even further than looking at it like the big numbers, understanding those rates is key. You got to know that so you can schedule. And so what we all sat down and kind of worked out with between, Bobby, Steve, Leanne, and I sat down before this and kind of talked through some numbers out there. And we in our contract at Purdue had 8,000 as our baseline for our carpenter. But Bobby was throwing out, hey, we're getting more than that stick built. And honestly, we're getting better than 8,000 square feet. So big picture, thumb in the air kind of thing. If you're doing some pre-con work or trying to estimate the stuff, kind of planning on that somewhere between 8,000 and 12,000 square foot per week spits you out a pretty accurate number of what you should be targeting as far as production is concerned. But that square footage includes the walls, floor joists, and the sheathing for the floor above. So that's a whole floor. And then manpower from that, you're looking at crew sizes of anywhere between 8 to 10 guys either stick building walls or lifting your panels, and then another 8 to 10 guys that are following your wall crews with the crane, setting your floor joists for the roof above, and then nailing down your sheathing.
So scheduling and pre-planning. So when you're looking at sequencing and constructability, just making sure you're doing multiple cover inspections per floor so that you can speed up the process. We split ours into like the north and south element portion, then north and south of the commons, and then north and south of the A-loft, so that each floor we could go on to the next phase. And then also when you're creating your phasing plan, not getting stuck just in the framing aspect, but like looking beyond that. Okay, what has the most finishes? What's gonna take the longest? So we started on our element side because they have the extended stay units, so those units were gonna take longer. So we needed to start on the element, work our way through the commons and out to into the A-loft side. And then pre-rocking, just making sure you're getting all your pre-rocking in before. Some of the common places are in your ceilings and corridors, top of your interior partitions, mechanical electrical rooms, your baths and showers. And then one that's important is like the stairwells, making sure that you buy it out with your framer so that whenever they're framing those landings, they can make sure that they put their pre-rock in there so that you're not slowed down or anything.
So this topic right here, we wanted to almost have a little bit of a group discussion on this one. So I think the settling of wood is always, it seems like it's different. You get mixed answers from everyone. At Uncommon, we came up with a unique situation where our vinyl window installer didn't want to begin installing windows until after the roof sheathing and basically all the structure and everything had been completed. And we wanted to get them started as soon as wall openings were available, and we kind of had a tieback in place. So what have you guys come across? Because for us, we were pushing that, but we didn't really understand, or we're trying to still figure out what the risks of maybe installing our vinyl windows ahead of the roof and all that stuff being in place. I mean, has anybody else in the room come across a situation where, the sequencing with your windows or any other type of items like drywall, with the fear of drywall cracks and things like that? Anybody come across anything like that or have any stories to tell that pertains to those types of things?
We had a situation in Denver where it was two-story all wood structure with wood roof trusses, and that was the consensus was you don't want to put in any windows or drywall until you have your roof trusses on.
Really? So did you hold off then? So none of windows and no drywall went until you had the roof?
We put in what we could. I mean, we tried to rip some drywall because that was a gypcrete project too.
Okay.
And that's kind of the
Heavy
precursor for the gypcrete.
Sure.
Was getting that drywall in, but to truly go at it full bore, and in Denver with all the piece workers that are out there,
Okay.
nobody really wanted to commit to that because it's like topping out a building. Nobody really wants to go in there and do all that tedious work. They want to do all the production work.
Sure.
So that was a difficulty, yes. We experienced that. We just had to figure out ways to work around it.
So it's not like a wild theory for a window guy to get freaked out about putting windows in before you're topped out with your structure.
Depends on a lot of things. Depends on your grade of lumber, your type of lumber, what your moisture content of lumber, it's gonna shrink, so.
Sure.
Anybody know up to how much you can expect out of a floor? Shrinkage?
I thought it was like 3 or something like that.
It could be as much of an inch as an inch.
Right, a lot of times
You
it's
can
been
lose.
identified somewhere in like a structural document. Kind of similar to like a
I don't know what's on the
geotechnical, like you should
documents.
experience half inch and an inch.
You can go into, is it AWI, Woodworking Institute or whatever? There's a lot of data there on it, just because, with some of these state tests I've had to take, I've had to read a bunch of that crap. But it's all there. But, I mean, yeah, it can move on you a little bit. It depends on how far you go up. I don't know exactly, that's going to be a case-by-case deal, but that definitely should be a topic at your kickoff meeting, and that's the time to have that discussion and weigh the risk with, the executives or whoever else, so you can say, hey, this is where we're at, and this is when we're going to put in the windows, so then it just doesn't catch you off guard when you're out there in the middle of it, about ready to start windows, and nobody
Sure.
wants to put them in for another 6 weeks. That would be a problem. As long as it's upfront, analyzed, and the decision's made, you should be okay. But do you guys know where your shrinkage is? Do you think it's the 10-foot length of stud that shrinks? It's the flip side. It's like if you have some of those joists, the end of it shrinks and more that it constricts and narrows the board. So that's where you lose everything. Not the long length. It's the other side that comes out. You would think it'd be the opposite, but it's not, just because of the properties of wood.
Yeah, well, it seems to come up a lot, and for people that have done wood buildings for the first time, it's like, you don't know when to call BS on something. It's like, it's gonna move an inch on you, it's hard to be able to know when to.
I can't say I've ever seen it move an inch. I think some of the hotels, some of the relief angles became a big deal, and to have them with the brick and when to add the brick and have enough, like the angles and caulk joints, so you can have a little bit of compression as that material moves, for sure.
Remember some of the difficulty we had is I think we asked the structural engineer if there's a concern, because we first produced that question or that concern, and so we're like, well, let's RFI it. Well, the downside is the trusses oftentimes are like a design build, like a wood roof truss. So they defer to that entity, and they don't want to put their name on
Well, I
it.
can put the name, when I talk to guys, they put a factor of safety of 3 on everything they do,
Right.
so they're not gonna stick their neck out there for you if you ask that question, for sure.
I mean, it's probably the first floor that's had the greatest of concerns, right? Like the first floor is gonna be 3/8 plus 3/8 plus 3/8 plus 3/8.
Yeah, I mean, really the right way to do it, kind of what we're doing a hybrid, but 6 stories of wood framing, or I guess you assume that there's gonna be more movement than on a 2-story or anything like that. So we actually kind of shifted our phasing, but we're gonna load drywall on the 5th floor first, and that's gonna preload the building. And we're gonna start our windows at the top, and we're just gonna top down. But really, it's not just the roof structure. I mean, they really say you need to have some drywall or at least have some sort of weight in the building too.
Well, and
Whether it's legitimate, you gotta kind of weigh the pros and cons, and we were able to not delay our drywall, but also kind of accommodate and make sure we're
And if you're going
doing the best we could.
If you're going all the way up 5 stories of wood, time you get to the top, those bottom floors should be compressed and loaded too, right? So
I guess you could also oversize your rough openings as well. I mean, it's probably too late now, but oversize them. If they would have been a 1/4 inch, you can make them a 1/2 inch. So that way, if there is some settlement, then it's just a larger caulk gap, whatever that acceptable distance is. And then same, you could also leave the drywall off the floor if you have some type of wood floor base or something that could probably overhang there for a little bit. Maybe it's a little more blocky at the bottom.
Well, we didn't want to derail the training, but it's good to get that input, because I mean, that's kind of some of the things that you kind of have to talk to 1 or 2 people to really get that type of knowledge from. But
So I mean, to Kendrick's point though, so if all the shrinkage is coming out of your truss assemblies, then really you shouldn't most of it's coming out of your truss assemblies. You shouldn't have to worry about ROs for windows because it's not coming out of your long lumber anyway.
Yeah.
What you do have to worry about, and we had it at streets, is obviously when you're coming up with facade's going to be pretty rigid, and that building's still going to be settling out as you're stocking with drywall, HVAC equipment, all that stuff. So figuring out what kind of expansion you have to accommodate for in your facades so that when it does settle out, you're not popping things and you're not putting facade on too early before the settlement comes out of the building anyway. So those would be my concerns. I wouldn't be as concerned with the openings themselves because I really don't think you're going to see much shrinkage in those openings.
You can do a case study. Laser measure your window openings whenever you're on the first floor, and then after you've got the sixth floor on, see if they shrink.
That's not a terrible idea. Take some survey shots and see.
I think our wild horse building takes into account like up to 2.5 inches of settlement. Isn't that what it is in the windows and stuff? Because we don't have relief angles.
Yeah, we don't.
They take care of it all in the windows, but we've got a sheet metal flashing detail at the head and at the sills so that that building can shrink down around those windows.
We'll have to see how it plays out. But like, as you guys can see, I mean, deciding when the windows go in, when you can start drywall, that's critical for planning your project and scheduling it properly. So having those details worked out, have those specific pointed conversations in your pre-con meetings with your subcontractors, with your drywall guy, with your window guy, with your framing guy. Make sure you have those things and then put them together and figure out how you want to do it as a team. Like Kendrick said, bring your directors involved in that conversation. If there's a little bit of risk involved, they'll have to make have some meetings and make a decision. So appreciate the input. All right, so out of scheduling, once you move out of it, one thing you really need as you're working on your scheduling is having a phasing plan. So what I wanted to touch on is a phasing plan should not be a foreign type of thing to anyone in this room. Most projects, you've got some sort of phasing plan that you're doing, and all you're really doing is breaking a project into different areas where you're focusing different work or pushing work ahead sooner than others and breaking it up. So this is the footprint of the Uncommon project, and schedule drove us having to do a phasing plan. And why we did the phasing in this manner is we're building the project in towers. So we're building this project up to the roof level, getting a roof on it so that we can start our drywall in this phase rather than building all of level 2. Oh, do that every time. Building all of level 2 and having to wait to build all the way up before you can start any drywall. This allows you to start other trades quicker, and this allows you to really get things going. So hopefully by the time you're into the job, you've got places that are sitting empty, punch listed, ready to go, and you're just you're not having to worry about finishing the whole job at one time. But it's obviously critical to have this phasing plan at the start of the project so that you can schedule it, because having a phasing plan changes your schedule completely. So knowing what you want to schedule and knowing square footages and things is pretty important to have. So you got to have full subcontractor buy-in into that. So having this early, you got to make sure that when you're having those buyout meetings, you're having your subcontractors aware that they need to be breaking up their crews for this, prepping to have potentially 2 crews working at one time in different phases. So everybody's got to know. And kind of like what this kind of ties into what Kendrick was saying, you got to manage your design team, the shop drawing review, and the procurement process. So if you're going to phase a job, you have got to make sure that not only do your subcontractors plan to break up their shop drawing processes so that you've got them in phases, but you've got to have your architect, structural engineer all prepped and ready to be reviewing them in broken up phases like that. And then once you get those approvals, you've got to make sure that your subcontractors then follow through with that and they procure those materials in that order with their suppliers. So if you have one of those chains break in that line, you could derail a whole project if phase 3 starts getting made before phase 1 or something like that, and lead times can get all jumbled up. So having those ducks in a row early on is very important, having everybody bought into that. And obviously, you've got a guy drawing up your panels early on. Answering RFIs and getting the design team involved in questions is so much more important at that phase because the answers are time sensitive, even more so than on a typical job that if you can stand to wait. But if you've got a whole phase of panels waiting on design coordination, I'm not answering an RFI promptly from your design team or from internally, that could really cause major problems with getting your panels in the order that you need it. So I wanted to show a picture. This is from a few weeks ago, and uncommon, but I wanted to show you, this is what, putting a phasing plan together and having it midway through execution, this is what it looks like. So this was at phase one. We've got our 5 stories of wood built up with our roof sheathing on and with our roof eaves. I mean, we've got roofing going on as we speak right now. But this shows you that first phase. Our second phase is down here. We're on our, this is the 3rd and 4th floors right there. So you can kind of see that phasing at work. We're pretty much topped out with our wood framing in our phase 1. We're midway through our phase 2, and we haven't even started our wood paneling on our phase 3 yet. So look at it, put your hard hat on and think about it. I mean, we've got MEPs roughed in through level 5 over here. We've got our pre-rock in. We're prepping. We've got our gyp created under our shower bases and our dead spaces already in place. We're teeing up and getting ready to do our drywall in that phase of the building. We're still just getting ready for the MEPs to start over here. So we've got that staggered flow going on big projects like this with tight schedules. That's the type of thing you've got to have working for you to make sure you can fit all those things in and get it done by the time your due date comes. So we're going to jump into now the site and project logistics. This is like the bread and butter of field operations, right? I just took a snapshot of what our early conceptual logistics plan for the Uncommon project was. Kind of shows our access from the road, our site perimeter, fire access lanes, and kind of where we'd be storing things and where our tower cranes sit.
So for your site and project logistics, you need a large laydown area for all your lumber and trusses for it to be on site. It needs to be out of the mud. For our project specifically, we didn't. It's kind of cool whenever you contrast the 2 different projects because we had a huge site, whereas they did not. So they actually had to have a separate place to get all their laydown area. We just needed to put down some rock and we could get everything there. It was very, very, a nice luxury to have. And then just reviewing lifting plan and where the crane's going to be at, and make sure that area stays clear. So make sure you don't have any guys put their job trailers there or something ridiculous like that. And then something that we specifically had to have was a construction road for emergency access, how to be able to go around our entire project before we could start going vertical. And then as well as depending on your jurisdiction, I'm not sure if that's a requirement for everyone, but all of our fire hydrants had to be live before we went vertical as well, since it was a wood framed building.
Yeah, that fire thing applied to us too. I mean, if you're in wood construction, you're building combustible materials. So that puts you in a different category than if you're doing metal framing and concrete, So like Leanne mentioned, having a live fire hydrant was a requirement of her job. For us down in Arizona, we needed to have a live fire hydrant. We also needed to be taking up a standpipe that could be made live by the fire department if they needed to take a hose to areas, So whatever floor we had framing going on, we had to have a riser up to that floor. That's pretty standard stuff, though. You're going to see that pretty well across the board, across the country where you're at, with maybe a few exceptions. But those are the important things that kind of keep in mind from laying out your project and getting it going on the logistics side of things. So tower cranes. Tower cranes are, becoming more and more common on Brinkman projects, it seems. And we wanted to take some time to kind of review the logistics and planning that's associated with having tower cranes on your site. The rise at Chauncey, we had a single tower crane because our footprint was small enough that could be serviced by a single radius of a tower crane. And we had to leave out in our structure itself, and the tower crane was in the building. Uncommon, we've got 2 different cranes. Our footprint is much larger than say what Purdue was. So the big difference was in order to be able to service both areas, you can see the swing radius of those. Like this crane can service, 3/4 of the site, and that crane can service 3/4 of the site. So knowing the logistics and the size of the cranes and your budget, is really going to drive how you end up laying those tower cranes out. So your project has tower cranes on it. You get them bought, you bring them, or you get the subcontract bought out. What's involved with that? Is your a site team getting ready to set up and plan for that? What do you got to think about? So as simple or as silly as it may sound, it's really important to make sure you coordinate the elevations of those things. You don't want to cross streams, you know what I'm saying? So you don't ever want to have a situation where your tower cranes will conflict with each other. Obviously, this tower crane could drop a cable and conflict with that one, but the heights in which we coordinated it in Uncommon, they don't have the risk of swinging into each other or hitting each other as far as a mast or boom standpoint is concerned. Let me show you one other thing too with these. So our site perimeter is kind of this gray area. That's kind of our building footprint. Our site property goes about 20 feet beyond that in every direction. We had our crane boom extending over. So, I mean, there's a Chick-fil-A here. There's a student church, student ministry with the campus right there. And then we've got an Embassy Suites hotel on that side. And then we've got an ADOT highway on the other side. They're all very tight site. One thing to think about, depending on where you're at, Arizona required us to get permission, or the local jurisdiction required us to get permission to have these booms swinging into the overhead air zone of these properties. So we had to go get air rights. We had to get air rights, and or we had to get permission to use their air rights. So we had to go through, get letters, and we finally got approval for that. But it took actually a quite significant amount of time and good conversations with the neighbors to make sure that they were okay with that. Some were a little concerned, like a tower crane. There was that news about New Orleans and that tower crane just fell over. So some people were a little more concerned and required a little more persuasion. So
I was going to say, did you have to get FAA approval as well at that particular site?
we were just far enough away from the airport where we didn't have to get FAA, fortunately. We had to do that at Purdue though. We were tall enough and we had to get those permits and clearances and things.
But you're right, you gotta check that first thing, because that could take months to get. It's 4 months, 6 months in some bad cases.
Yeah, well, an interesting thing is that the Indian tribes locally have to give a sign off on FAA clearances, because if they're visible from a certain area, they could have a say in that. That is a part of it. It's interesting to think about. Something you never think of.
That's a new one.
Yeah.
So with the crane station, you wouldn't have been able to get permission. Would they allow you to set up a crane and just not go over that person's property? Or if it's in the crane path, and if the crane could?
Well, it's funny because we were lucky enough that on 3 sides we got signed okays. ADOT was not willing to let it. They were going to make us do traffic shutdowns and things like that. So one adjustment we had to make, we actually took this tower crane and we shifted it about, it was like 15 feet further into our building footprint so that our swing radius just misses the ADOT travel lanes. So that's one thing too to think about. We fortunately had the luxury to be able to kind of shift and it didn't kill us. But
Was that with a load or was that just?
anytime, if the boom was over traffic lane, it was going to require a shutdown.
Right, they're weather vanes, so when you're not there, you have to let them swing with the wind, so you can't really control which direction they're going to be.
Right.
Unless you design your foundation to lock them down.
Yeah. So. Okay. Talked about the tower crane. Let's touch on one of the most important things when you talk about site logistics or field operations, safety. We've got some examples here. So any stick build project that you've got some height to it, you've always got leading edges and things like that. And making sure you take these things into account when you're building panels and things like that is really important. Leading edge protection. This is the system that our carpenters are using at Uncommon to basically give us some protection when you're up there inspecting and putting that sheeting on. You can see they put these in just far enough so that when the wall panels for the next phase comes on, they have just enough room to set those exterior wall panels outside that barrier, and they can knock all those in place and then brace them, and then they can pull these barriers. So there's basically an unbroken edge protection as they build these upper floors, which is a pretty slick deal. Another really important thing with safety is controlled access zones. Obviously, if we're using a tower crane like this to swing panels and set, this is our 3rd floor. They're taking panels up to the 4th floor to stand them up. You can't have anybody working in that floor beneath. If a load comes loose or something like that, you don't want to have people working in that area where those panels will punch right through the sheathing or the decking and potentially hurt or kill someone. So the way we've been working is you have an empty floor in between where you're putting up wall panels and where you've got MEPs or anybody else working. So managing that's a really important, that controlled access zone rolls right into the MEPS scheduling. You don't want to run into your MEPs until you're a couple floors ahead with your sheathing and wood paneling, just for safety reasons. No brainer, we're going to put on here, crane certs. If you got anybody operating that tower crane, you need to make sure you got their crane operator's card and certifications on file. That's a Brakeman requirement for any cranes that you have on a job site. So wall panel bracing, we've taken a couple licks to the chin at Uncommon. Our first day of setting panels, the carpenters were up there bracing their wall panels and they were just nailing willy-nilly to the sheathing. Had a little wind come through and had our first wall panels that we stood up on the job pull out of the sheathing because they didn't hit anything solid. We had some wall panels fall down off our 2nd floor. So we learned very early on the importance of making sure that the bracing is not only in place, but in place on something sturdy. It's got to be biting into floor trusses, something like that, so it's not going to pull up. Just this past weekend, though, we found out how straight line winds can derail even the safest of bracing practices. I don't even know what the wind speeds were, but we just recently had some very, very strong winds blow through Flagstaff, and actually on our 4th floor of phase 2, we had panels get blown off of the building and land on a car in the adjacent parking lot of the hotel. Our window installer was sitting in his car that the panels landed on. We're still sorting out that whole deal, but those are some things some very real risks that you have with panelized projects. They're not getting anchored like you would with the stick-built project and everything's kind of locked together. These are going up in big pieces and are getting braced and nailed to each other. So learn from us. If you're working on a panelized project, just make sure that you've had those safety meetings, make sure you've got the protocol for what your carpenters are doing to make sure that these panels stay and that they're aware of their surroundings and they're bracing them and anchoring them properly. It's important. Lives could be dependent on it. Some other things that we've learned on a safety standpoint and what we have kind of seen and witnessed on site. So how these tower cranes are being used to lift these panels and set them into place. There's a whole slew of ways you can have tie-offs and certain clip-on devices. I couldn't find any pictures quickly of what I wanted to show you, but there's all kinds of devices where they kind of clamp into the wall panels and lift up, or even some of them that are screwed on, like you screw them to the face of a sheathing and it'll lift it up. We had issues where the carpenters weren't using those hoisting devices properly, and you screw a plate to the face and lift it up, and you've got that whole panel and all the nails holding that panel together. They screwed that same device on a top plate, so when they went to lift it, all that weight was on one board that was held down by 12 or 15 nails. Well, they lifted that thing up, and as they were setting it in place, all those nails came loose because there weren't that many nails. This panel dropped. Unfortunately, everybody's toes and hands were all clear, but a panel came loose. And Steve was on site, and we all were standing right there and happened to watch it happen. So we were able to address that pretty quickly. But a lot of these things are like, these guys do set hundreds of panels in a day, and they just get negligent. It's that easy. So being aware of those types of things is really important when you're working on projects like this. Sorry, I feel like I'm talking endlessly. Shocker. If you've got those tower cranes on site, some things you need to be thinking about. How are you going to power those things? Tower cranes require power. They don't have their own internal engines. So you either got to have a temporary power from the utility set up, you got to have your permanent building power set up and ready to accept those, or you got to have it powered by some sort of generator. So think about those things, because it's maybe something that might slip your mind, but that could end up being a very, very large cost to your job if it gets overlooked. How am I going to power this thing? Also with the tower crane, you may have, all kinds of space or not a lot, but if your area you plan on staging all your panels or your wood, your bunks of wood, anything like that, if it's outside the sweep of that crane, it could be a problem. And then I've already gone through the air rights and airspace permissions. Agreed. Okay. So the next important thing with site logistics and planning is you've got a tight job site. Think about having a laydown yard, having a place separate from your actual job site where you can bring all your big deliveries. You don't have to worry about traffic control or traffic restrictions. In some places, it's more than enough room you can plant. Leanne and the project in Kansas City had the luxury of acres and acres of free open space. At Flagstaff, we didn't have 500 square feet to spare. So what this pushed us into is having a laydown yard about a quarter mile away from the job site where all of our big deliveries go. So we're shaking out panels and we're bringing in all of our wood and everything like that to a site away from the job site. You can break down all your deliveries into smaller, more manageable sizes, put them on smaller trucks and bring them in whenever you want.
Is that what we're doing on most of our zero lot line trout projects? Like, do you just have to budget for that? How the hell do you handle that with the order?
It can go a couple of ways. I mean, I think this is an absolute necessity for a wood job. If you're panelizing or you're doing stick build, you have got to have some area where you can bring those materials in that is separate from your job. Purdue, we weren't panelized. We were able to do that whole job on a deliver as needed basis. So all of our metal studs showed up exactly for like on a floor by floor basis and they threw them on the floors. So it really depends. But I think with wood, with the amount of logistics that goes into getting the panels on site, shaking them out, getting your deliveries and bringing them to site, you gotta have some space to work with, whether it's on site or off site.
Yeah, if you don't do that, you're gonna have a yard somewhere where maybe it's where you're panelizing, but you're just gonna have to sequence every truck the way they want it to arrive when you want it, and you'll have to pick right off the truck. So this at least affords us the ability to get, an entire floor, get trusses ahead of when we need them, to where we're not procuring or getting materials on an as-needed basis. So it builds you a little cushion in your schedule. It helps you get ahead on procurements where you're not getting deliveries on time. Definitely recommended if you're making a lot of work for yourself to try to have to schedule every truck exactly when you need it to hit the job site.
Probably trucks break down, and stuff like that always happens. So you'll end up probably getting shot in the foot trying to wait to get everything right when you need it.
Steve, what do you guys pay, like $1,000 a month?
So our concrete sub actually procured, but we have a lease on that for $2,000 a month. And we just put some fencing around it, some rock down, and it's been good.
Yeah, so like a truck driver or how do you?
No, we bought it out with our sub. So like the wood guys, we're sourcing our wood from separate from our installation, but all of our materials hit the job or hit the laydown yard, and they have shuttling materials from the laydown yard to the job site as needed.
That's your installer or what?
I install it.
So once they're delivered, the fabricator's responsibility is.
Correct. Yeah. So our laydown yard is covered underneath our, extension of our site property and all of our insurances and things like that. It's just basically our site, but an extension of it right down the road.
Have we done that before?
Sure we have.
I was dealing with the problem really right.
Especially.
I guess part of that to acknowledge is they're two separate contracts, the furnish and the install. So most instances that I've been involved with, it's all a lump sum package, if you will. So the framer has the panels also, so we haven't had to worry about taking that extra step to make sure that that material was available. It was all there, burden there.
Sure.
Kind of the same with the crane as well. I don't know if we're renting this one or not, but there just comes the more risk with not renting and more coordination with insurance. You'll probably tell us all about the time with operators and the up and down a ladder, and how much that costs too.
Yeah.
It's probably more imperative if you have those two contracts.
So, anytime you run into the chance of you can't produce enough material as fast as you install it, offsite yard's a great idea. we've done it a lot for precast concrete panels. It's a great way to do it.
Oh, that makes sense.
Just when you get into bobtailing and one way on trucks, they get a little excited. I mean, it could cost you 10, 15 grand on a project, but yeah, it's a good way to mitigate the risk of your factory not being able to keep up with your installers on site.
Yeah.
Or they should probably be
Factory
stored
delivery schedule.
out of the rain or covered, kind of back to that shrinkage comment earlier.
Yeah.
The wetter they're going to be when they go up, the more shrinkage you're going to get.
Yeah, we're lucky as hell to run climate in Flagstaff, Arizona. So, yeah. But you gotta take that into account though. After. So just kind of piggyback on those things, not only is it good for just the logistics side of things, but that laydown area allows us to have a place to receive those shipments. And our subcontractor actually has guys at that laydown yard unloading, and they're shaking them out, figuring out where everything goes and making sure they're taking quick measurements and making sure the panels are right. We found issues in the laydown yard before the panels have gone up that has allowed us to try and get ahead of problems that if those panels would show up at the job site and you would have gotten to put it in place, you would have been like, oh crap. We've been able to get ahead of some field QC items by having them checking these panels when they get them rather than bringing them to the site. But it helps keep the job from being cluttered. Even if you have a tight job or even a job site with some space, having that laydown yard away from the job site helps keep that operation separate, and all your other trades are able to move around much more freely than if you had hundreds of wall panels stacked up on your site.
Did you fill up more storage material too?
And then kind of already hit on it, but the materials brought to the job site on an as-needed basis in much smaller, more manageable deliveries rather than having a giant semi come with who knows what on it. So. All right. Oh, yeah. So we threw this in there right before the meeting. We thought it'd be a good thing to touch on, but field operations kind of goes hand in hand with having your pre-con meeting, having that sit-down meeting with your framing contractor, making sure weeks, if not a month or so in advance, you've got all the details kind of talked through, ironed out, and agreed upon. So having your job-specific agenda, like pulling down that Bridgman template and going through it yourself one time and making sure that you've got questions and things that are going to be applied to your job and be useful. It's really important to do that. Very, very important. You'll get some questions out of it.
So isn't that one you guys flipped into Procore as a standard template based on this one? I know you guys came up with some pretty good templates on that job in general, but framing is one of them at the time.
Our QC was one that we had a really sweet template in Procore. We don't have that sub pre-con agenda in there per se.
Yeah, but taking, the idea is you come up with whatever it is, 12 things for one project, right? Talking points, initiatives, QC initiatives, what do you want to call it?
Yeah.
And that rolls into some type of template, so you have all that figured out on the side, on some of these larger complicated projects. So.
Yeah, I've got a PDF on our last sheet with I've got like a Procore slide. I think I know what you're talking about. I've got a little example of that.
Well, if not, it'd be good. It'd be a good opportunity to fine tune that, maybe push it out as an opportunity to use from the knowledge from the different wood framing projects while we're having this conversation this month. I think that'd be a great thing to have.
Yeah, let's touch on that. We can brainstorm a little bit on the Procore side. So I'm curious to see how much everybody else is kind of utilizing that tool. But that pre-con meeting is the absolute time that you need to be going through the phasing plan, the job site logistics with your wood framing guys to make sure that they know what they're getting into, what's coming, and what they need to start planning for.
So field operations, some quality assurance and quality control, just your tie-down systems and anchor bolt verification. I think, so one thing that we found that was a little bit different from our project from theirs was they did a GPS surveyed locations where we just pulled ours off of our edge forms. So that's something that's a little bit different. And then just looking at your shear wall nailing patterns, which I know we touched on a lot last week, and your rated walls and structural walls.
Those TDS and anchor bolt locations are really important. You've got a mildly reinforced slab. You've got that ability to kind of rough into your foundations. You've got a podium that's PT like we had at Avid Uncommon. The flexibility you have to go after the fact and put in missed TDSs or chubby smacks or your anchor bolts it's extremely difficult because all your PT coring requires x-raying and stuff like that. So we took that extra step. We hired it with one of our wood subcontractors to bring out a GPS guys that specialized in doing surveys and QC and make sure that all of those anchor bolts and everything were exactly where they needed to per plan. So we definitely benefited from paying a little extra to have somebody come out and verify those things down to in that size.
Did you use the structural plans, the architectural plans, or your panel plans?
Yes.
All three.
Yeah, no, there were a lot of RFIs that came out of that question, exactly like who's right? We got a discrepancy between this wall and that wall, who's right? So we worked out a lot of those problems by having those panel shops, and we were able to bounce those questions off the structural engineer, and they were basically the ones saying, well, use this sheet or use that sheet and stuff like that. So there was a lot of problems that we missed because we had that verification process in there.
Yeah, so I would just kind of give everybody a heads up. So on here, I'm going to throw a number out here. We probably had 60,000 square feet of PT deck that we had to have laid out for us. And it cost, there was probably 10 trips for them figured. It cost us $30,000, and he laid out every J-bolt, every TDS, every plumbing penetration,
Yeah.
every electrical penetration.
He measured shaft openings in the slab. And
He checked our shaft openings, he checked our edge of slab to make sure it tied out with what the wall panel guy was gonna do. Probably worth, I shouldn't say probably, it was worth every penny to know that stuff ahead of time. And even like Garrett said, find the conflicts between architectural and structural and get an answer before we, because he come out as we were putting rebar and getting ready to pour the concrete. So we would get an answer before we ever poured the concrete. Very helpful. I would highly recommend, even that PT, I think it's a very good QC on our part too, if we could keep trying to push that.
that was a full-time job for Lori there for a period of time, making sure that all those anchor bolts and everything. And I think Jason was out there too, checking all those things and coordinating those. So it was really, really important, but some huge problems that if we didn't do that, we dodged major bullets. So really important.
So Steve, did he miss any? And if he does miss any, does that risk transfer to him since he laid it out, or is it still?
I'm sure he's got a clause in there. I don't know. I'm not aware of any that were missed, to be honest. So
It was like, I think we had like 3 or 4 out of like thousands that got overlooked. There were a couple times when we did our separate QC, like our pen and paper QC as opposed to GPS, that we found a few that they'd missed. But after the concrete was cast, we found like 3, I think it was. We were epoxying and scanning and epoxying. So very, very minimal.
What's the cost of scanning and epoxy?
I mean, a trip charge for a GPR guy is usually they're like $150 an hour with a minimum of like 4 hours or something like that. So you're going to spend a couple $1,000s to get a scan. And then you can put it on your concrete contractor, or whoever the responsible party is. Our concrete contractor was the one putting them in. So you can hold them accountable for missing them and not putting them in per plan. But if you can't figure out a way to disperse that cost elsewhere, you're looking at a few $1,000s every time you miss a couple. So.
yeah, figure out $1,000 that come out and see you.
Yeah, but the problem comes when you scan in a spot and you got a PT cable there. That's when shit really hits the fan, because you're gonna have to go back to the designers and have them look at shifting a whole TDS rod and the whole vertical elevation of a building. Those are the things you kind of hope you don't have to get into. So unfortunately, we haven't had that problem. So.
Did you guys have any intention about breaking in during the course? It's not really a question for this, but I'm curious.
No, we've gotten pretty lucky. We've had some not straight ones, but nothing's ever been broken. So.
I will say, so if we're gonna talk about shear wall a little bit, I mean, one thing that we kind of interested, I didn't know this before, is I assumed that they would put tension on them, but in reality, they don't. It's really, as the building loads and settles, they're allowed to retract on themselves, but there's no actual anchoring that somebody sits up there with an impact and just torques it to a certain amount, which I thought that was kind of interesting, because like you can walk up and grab the rod and just kind of shake it. Right now, there's probably something on them, but it's not like tight as a guitar string. So it's kind of interesting.
Yeah.
I don't know if anybody's had any experience with that, but I guess we're expecting our building below here shortly.
Okay.
So kind of going off of the quality assurance, that kind of starts when I did this middle review, just making sure, since we didn't do the panel shop drawings, making sure everything was like on one page to, say I had to talk to my foreman daily and go give him paper after paper, hard copy, so that he would get everything right. He was in the loop of everything. So just trying to get all of like your mechanicals, and at that point you can kind of, everything bleeds into one another. So you can really start to like coordinate your mechanical drawings with your elevations, or your structural drawings with your ceiling heights and everything. And that's where you kind of get ahead of anything that you might cause issues later down the road. So one thing that we had was our, all of our corridors, we had choice going through all of our corridors. So we changed those to 2x10s instead of 2x12, or 2x10s or 2x12s, instead of having those joists go around there. And that opened up a lot of space for all of our MEPs to go through the corridors. One other thing we found whenever we were just going through and trying to get ahead of anything was a detail that's up here. Basically, when that plywood in the floor deck encroaches onto that 2-hour shaft, we had RFI'd that, and essentially we ended up just going to a fire-treated plywood for the floor deck. But typically on the other projects we've done that's been wood framed, the deck will end before it goes into that 2-hour shaft. So we asked if we could switch it, and they said no, that the plywood still needed to go through there for like lateral loading. And I think you guys actually might have had the same detail come up, so that's something to look out for.
Similar issue, yeah.
Yeah. And then we're not going to dive all the way into it, but because I know she went over everything with the plumbing and making sure that we didn't have any conflicts with that. So we did our overlays as well, but this was just an additional document we provided to our truss manufacturers to make sure that we didn't have any issues with any of our plumbing penetrations, essentially going through each room layout and making a no truss zone, which ended up being really successful. We didn't have any issues with any of our plumbing penetrations hitting any trusses. So I think that was very good for us if anyone is looking for a way to avoid plumbing.
Yeah, this wasn't something I thought of until just now, but we had this problem at Uncommon. Our first few floors that we started laying out floor trusses, the trusses were landing right where toilets were, right where showers were. We'd sent through all of the MEP CAD files to our truss designer early on, and they'd asked for them specifically so they could coordinate the trusses around MEPs where they had it. So we kind of took our foot off the gas on that one, put it on autopilot, thinking that they had it under control since they'd asked for it and whatnot. Well, came down to time, and we had a lot of trusses because all the trusses are in place 2 floors before the MEPs start. Our plumbers had to go through, once they realized we were having these problems, the plumbers had to run up through the rest of the building and catch this and adjust it. So we had to make a quick adjustment, like when we were 3 or 4 floors into the project, to get those truss guys aware of where our plumbing stuff was and to get those trusses out of the zone. So the planning that Leanne and put in on a loft was something that we had assumed that our subcontractors had that didn't end up happening. So this is pretty useful information to kind of plan those plumbing locations out early on.
And then this is another, just kind of reiterating the fact that knowing like where all of your mechanical, if it's going to be up in the duct space or if it's going to be below the lid, that's really important whenever you're looking at all your joists and everything, and making sure you're marking up like get with your mechanical contractor. Okay, so the duct's this big, how much more space do you need? Is it going to be lined? Is it going to be lined, or is the insulation going to be around it? Like, knowing exactly how much space each one needs is really important. And then another thing that we kind of ran into as well is our roof hatches, making sure that you're coordinating. If you have the alternated tread ladders, the shaft sizes sometimes impede on that, and then your ladder will end up, you won't have clearance for the guys to get, the firemen to get into the ladder and go up because of the rails and everything. So that was something that we ended up changing early on in the process so that we didn't have any issues later on. But yeah, just coordinating, I think, at the beginning and seeing how everything comes together is probably the most beneficial.
You've got some walls of text here, like some of the stuff you're calling out, that's your DOAS
Yeah.
on the roof. So this is like a roof truss plan.
Right, yeah, so this one's like our roof truss, so yeah, all of the larger, like all of our DOAS units and rooftop units or makeup air units, to incorporate all the rough openings, make sure that whenever that joists come up, or the trusses come up, that those are all accounted for.
So this kind of looks like you had your shop drawing in one hand, you had the mechanical plans, and you went through those, marked
Yeah.
where you got stuff, you went through the architecturals, like we got a roof patch here.
Exactly.
Make sure you got room. So that,
Yeah,
think about those things, because that's a project engineer or a young project manager thing that you're going to be doing. You're going to be going through making sure those things are coordinated.
lighting, yeah. Exactly. And then this was one detail that we actually ended up doing whenever we were coordinating our corridor heights. So we had a makeup air duct coming in through to each of our units. And in order to get down below, we were going to end up having to drop our ceiling. So in lieu of dropping our ceiling height, our structural engineer allowed us to carve out the bottom top plate and then just adding 2 cribble studs next to it so that we wouldn't have to drop our ceiling height and we could still get in under the fire rate lit, so we wouldn't have to add any dampers or anything.
Okay, here's kind of like a quick snapshot of what our structural plans at Uncommon look like. This is a concrete slab level, and this is calling out where our shear walls are. Each one of like W4, W6. You know, each one of these walls represents not only, you know, a location where you've got a shear wall, you know, your stud wall with your plywood on the face of it, but each one of these has these TDSs on the ends, and each one of these little call-outs is telling you how much the design tensile force on that TDS is going to be. So, you know, we've got some 2 kips, we've got some 8 kips, you know, all the way up to like 14s and 15s, you know, so those numbers dictate, you know, you can look at that and you come down here to your charts, and it's hard to read, but this is a tension force tie down anchor schedule, and this shows you. So like if you've got between 13.2 and 17, you've got a 1-inch TDS rod that's sticking up out of your slab there. So each one of these is different, and you got to go through, and that's one big part of the QC process, is going through and checking those things, because you miss a rod diameter. If your subcontractor goes and puts out a 7/8 inch rod instead of a 1-inch rod, your capacity in that rod just dropped from 13 to 17 down to 9 to 13. So you completely screwed up a structural design that you'd have to get a structural engineer involved in. So those finer details are some of the things that are important to make sure you're checking out there in the field, because you miss it that first time and it's going to cause you some major headaches down the road where you're going to get the design team involved and potentially the owner. So keeping those things in mind when you're working with those TDSs and anchor bolts and things like that, it's pretty key.
Hey Garrett, the other thing to point out is the rods are in tension, so on either side of the rod there's those 4s with circles around them? Those are studs, so that's like a 2x6 or a 2x4 stud. That's a 4-pack. So you have to have 4 studs on either side of that assembly.
And they're structural.
Yeah, for structural. So the rod's pulling it tight, the studs are in compression on either side of it, but you know, probably could have done, we don't have too many conflicts, but definitely, you know, anytime you've got, you know, it's probably 24 inches wide is that assembly right there. So you pretty much need to go through and check that against any, you know, plumbing vents, electrical boxes, anything like that. I mean, that's a pretty tricky spot in your wall that you got to coordinate. Probably if you can't just avoid it altogether. So.
Yeah, 100%. I've got some pictures on the next slide here, but one thing to note too. So not only do you have that rod size you got to think about, take a look at this detail. This is a reinforcing detail for a tie-down rod in one of these decks. There's like four pieces of bent, specially fabricated rebar that basically gets slipped around that TDS rod to lock that into the slab after the fact. So not only do you have to go check the TDS sizes, but making sure that reinforcing detail is in place. And I think this is even like a side view of that, how much rebar you got stacked up around each one of those TDS rods. It's important to check out. So this next slide, I've got some pictures from when Lori and Jason were doing a QC before our PT Dex report. There's no wood on this besides the edge forms, but it's really important that the QC for wood framing and panelizing or stick building, it happens far before you ever have a piece of actual timber on site that's going to be a wall panel or whatnot. So, we've got our PT rod or our PT cables in here, all of our reinforcing, and then we've got our anchor bolts here that go in for the base plates. And then you can't see it, but wherever on the exterior we have these anchor bolts, on the interior you're going to have these, I call them chubby smacks, the little plates that get nailed down to the bottom form that will stub up with these little flags that you'll screw your all thread down into at a later time. And then over here, here's a picture of the beefier TDS rods. And you can kind of see these reinforcing details installed at those points. You've got those anchor bolts that run there in between them. So that's kind of what it looks like when you're in the concrete phase. Got to be thinking, what's coming, what's wood, what do I have to have in place for wood? And QCing these things is really important.
So field coordination for stick build, it's a little bit different than panelized because you have to do a lot of it on site, and you really just have to go put a tape measure on everything. Like literally every rep opening, you have to go put a tape on. My biggest thing is just communicating with the foreman every day and have hard copies for everyone. Just continuously hand people hard copies and go over any RFIs. Luckily we had a pretty competent foreman, but I mean, depending on who you're dealing with, if you have like a good guy on site, you can go through that process with and just make sure he is up to date. That's really important as far as being on site. And then, like I said earlier, just making sure you're physically going and checking out all your rep openings with your rep opening log and blocking logs. You have to like put a tape on everything because you think, oh, like on a panelized, maybe you check the first third, I don't know, maybe you check every single one, but if you have a panel that's all the same, you assume like they all come out the same, but whenever it's stick framed, it's a different guy could frame that opening and you just have to check everything.
Yeah, depends on if the carpenter went to the bar. Then.
Yeah. And then some of the items that just to QC that we have lined out are the door openings, and then off of that, making sure you take into account your gyp crate for those, and then also your gyp crate will affect all of your like electrical rough-ins and any of those heights. So making sure you're accounting for your gyp crate, windows and storefronts, your PTAC and VTAC openings. So for your VTAC specifically, you're going to have your exterior and your interior like access panel, and then on your VTAC, just something to note is the platform height, making sure you buy that out with either your carpenter or your HVAC guy. We bought it out with our HVAC guy, so he could just do it as he went, which was really nice. And then knowing exactly what that is so that you can get that to them. All your shaft openings, so your elevator, mechanical shafts, specifically talking about elevators, depending on your drawings, like it'll not be right, so you need to make sure that you get that early and get all of that information correct. Linen chute and trash chutes, those are usually shown wrong on the plans as well. So making sure you get your shop drawings early so that you can get the right shaft size for those incorporated. And then your shower pans and tubs. Also, if you have a hood in your building, then it needs to be a non-combustible wall, so you need to frame it out of metal. All your stud packs, we kind of touched on that earlier. Ours, with our like ATS rods, we had 3 studs on each side, so a lot of them fell in like the corners of the walls, so that affected our electrical outlets and a lot for like our sconces, our wall sconces, that where our beds would go. So try to coordinate that early if you need to fur the wall out so that you don't impede on that stud pack, or how you're going to really do that is something that you can try to get ahead of. All your in-wall blocking, so that's your toilet accessories, barn doors, fire extinguisher cabinets, if they're non-rated, knowing if they're rated or non-rated, and to account for the drywall if they're a non-rated fire extinguisher cabinet, making sure you get your drywall put on the inside of their casework, TVs, FF&E, bathroom and living room dimensions. Make sure you take into account all your ADA clearances and your FHA clearances, your ATS routes, which we've talked about quite a bit, and then fire stopping, headers and shear walls. So making sure you're just checking all the shear walls and everything, make sure that all the nailings are going straight into that stud, because obviously you don't want to proceed if there's any blowouts on the side. And then we talked about the UL 305 last week, but on ours that actually came where the ATS rods were a lot of times. So they had to install our ATS rods, and then we had to go back and install that last piece of the UL assembly to make sure that it had that full assembly. So they were not the best about it. They missed a few here and there, so we had to get them to go back to install a few of those where the ATS rods were. And then third-party inspections.
I can hit on that for
Yeah.
sure. So just like with like foundations or rebar or, structural concrete, usually when you're panelizing wood or even stick building, it's structural components. So your structural engineer is probably going to have some sort of requirements out of third party. They're looking at it outside of just Brinkman QC or whatnot. So making sure that your owner is aware of what those third party inspections are, and making sure either they have them set up or you make a deal with them that we get it set up and they're inspecting on our behalf, because third party inspections are key. Sometimes the structural engineer won't give you the thumbs up unless you've had those third party inspections recorded and submitted for their review. So a blocking log, Leanne had mentioned this, and a lot of what was just on the previous slide falls into these next sheets. So Lori on Uncommon put these together, and I think, Zach, you've put together iterations of this before too on previous projects, right? But this is one of the sweetest things ever. Lori did a good job, and I think the fact that this has been thought of and came up with, it's pretty good. But what this basically is, it's a consolidation of all of your wood blocking in-wall items, all consolidated in one place. Usually if you're flipping through your plan sheets trying to check all the things that are in a wall, this is you're taking all the details and creating a PDF document, consolidating it into 3 sheets. So TV blocking's on here. You've got your unit blow-ups with dimensions on them. You've got, your blocking heights for your shower. You've got more like grab bar heights. Your ADA mounting heights for, your ADA grab bars and things like that are all required per FHA. And here's a shot, we've got all kinds of different door types in the units, and we've got the rough opening sizes listed out for each one of these things, and the rough openings as well. So all that information's right there, and I highly recommend that this gets put together. It's great for the project engineers, it's great for the superintendents to have this information. Just kind of continuing on that. Next sheet has kind of our FHA mounting heights for everything from an electrical panel all the way through thermostats and switches. Here's the electrical layouts, the outlet locations and the RCP where all the lights go, and then more bathroom. And these are our, just more layouts and blocking heights for the things that have to go in those units and in those bathrooms. It's really great. You put this together, you spend a lot of time. I know Lori put a ton of time in this on the upfront end to consolidate it all, but having it all ready, and so it's a quick, the day or two that you spend building this saves hours and hours and hours in the field. You could probably attest to that too, Zach.
You can give it to anybody and they can go do this. Yeah. So it helps tremendously with that aspect.
Yep. So then, using that tool, here's the bit about the Procore. So what we have been doing at Uncommon is we created a template in Procore in our inspections tab where we got every single unit number. And in Procore, it looks differently than this. This is if you were to go and print the report. But you can go through and, for example, Unit 202 is the first unit that we have on this inspection report. So we've got a blocking tab, the pass, fail, or NA. I'm pretty sure that in Procore, if you go and click fail, it'll allow you to open up an observation. So you can then say, why didn't the blocking pass in this unit? You can create an item in Procore that take a picture while you're doing it, and it throws it up there, and you're able to then start tracking why didn't Unit 202 pass, and you've got that list already ready to go, and you can knock it all out at the same time rather than having to go back and type it into Excel or something like that. We've got line items in every single unit for about 12 different things, and blocking is one, receptacle heights, rough openings, shower base clearances, light fixtures centered. So it goes on, and then we've got every single unit in our inspection reports in every single phase, and we can go through and check these things off, and we've got those inspection reports in Procore that we can refer back to. So that's a pretty slick way that we're applying Procore to be able to basically do a punch list before drywall goes up. But additionally to that, like that's kind of tying the blocking logs into inspections and in Procore, how it can be used. And the other big thing is our engineer of record. It was kind of different because of COVID, but our structural engineers weren't able to travel to the job site for the last few months, or since March. We were doing all of our concrete rebar and TDS and anchor bolt inspections. We were able to create inspections, title them EOR inspections. They gave us a numbered plan with all the things that they would have looked at if they were on site. We went through and took pictures of those things, created observations, or we created those picture templates and numbered them for them. So the engineer was basically, we did the inspections for the engineers, but they were able to say thumbs up, and they never had to set foot on the site. So maybe this is future thinking here, but we were able to basically perform inspections for the EOR without them setting foot on site using Procore. So. All right. So the best part of any presentation is the PISers or lessons learned, and we talked about this a little bit today. So structural stud notching, Leanne mentioned it, Steve brought it up. So you have these stud packs that are all throughout the building. There's usually some limitation depending on what they are. How much can you cut those? Can you notch them out? Do you have to leave them completely untouched? What's the deal? Those stud packs are on either side of the TDSs in every building. You can't touch those. You can't modify them. You can't even cut little notches out of them. We had a problem where those TDSs, our shear walls were on the corridor. So we had TDS on every single unit opening because our shear wall spanned from unit door to unit door. So you got your entry door and you got TDSs on either side, wrapped by stud packs. Well, what's the first thing you do when you walk into a room? You reach the side to flip on the light switch. Well, the electricians were limited by the kitchen. They started cutting out little 4x4 J-box sized notches in each one of those stud packs because that's where the light switch goes. So we had to catch that and get a remediation for that because you can't do that.
So structural engineer is a good source of that. Also, if you flip open the wood framing section in the IDC 2012, 2015, whatever it is, it's very specific about how many notches you can take out of joists and studs and things like that, or size holes, 1/6, 1/3. It'd be good information for you guys to flip open and read that. It'll give you a very good idea what you can and can't do.
Yeah. So that kind of rolls into this next one, the stud pack coordination with the MEP. So not only do you have those stud packs that are on the sides of TDSs, but structural walls usually aren't just a 2x every 16 inches. You've usually got 2x10s stacked in 3s on 16 inches on center. So when you do that math, that leaves you with like 4 to 6 inches between each one of those stud packs. If your electrician was planning on putting their electrical panel for that unit in that wall, they can't now. So thinking about those things and knowing, because that's a little bit of a harder thing for standard to like look at a wall and say that wall is not going to have enough room for the MEPs to be in it. That requires a little bit more of an in-depth dive, reviewing those panel shops and checking to see what walls we have space in and what do we not. That's kind of a unique thing with wood walls where you've got those spacing variations. Well, on the field side of things, wall adjustment coordination with the truss supplier. Say your superintendents are out there working it out with the guys, this wall can't go here. We've got to shift it 2 inches to the right to make all of our panels fit on this floor. If you make that wall adjustment, you don't relay that information to your truss supplier. That's a big deal. The truss supplier is bearing on certain walls with his trusses. And if you shift that wall, you could move a wall out of the bearing zone for a truss and cause a problem, and then you have to remake trusses or something like that. We've come across that problem a couple of times out in Flagstaff where it's caused some issues. They have to get some trusses remade for us. Material management, we hit all over the place on logistics and sequencing and submittals, but what the key with this material management is that submittal process, getting your designer in the phasing sequence, getting your designers on board with that, and then making sure that that procurement process follows through with the approvals that you're getting on those. So cannot stress enough that when you're panelizing these projects, getting that phasing, that sequence, those materials hitting the job when you need them to, it is almost critical for job success, for that to be ironed out and everybody be on the same page with.
Yeah, Gary, we also kind of to throw under that would just be with the nature of wood framing, where you're often, if you can buy a turnkey, great, but sometimes you can't. It's really just the management of the materials you bought and organization. So your concrete guy has all your embeds, your lumber guy has, or your wood framer has all your lumber you're buying. You know, we can be better about keeping an eye on our materials and being diligent with making sure that they're organized and keeping track of them.
Yeah.
It's going to save us money long, because at the end of the day, if you got a pour coming, you need the embeds, and nobody knows where they're at, you're going to order more.
Yeah.
And then when you find them a week later, it's going to make you mad. So again, a lot of times with the way we're buying lumber for these wood framing packages, you know, the way we manage our materials and track them and sort them and do all that's very important.
Yeah, yes, absolutely. All those little chubby smack pieces and all thread rods disappear in no time. And then crowning studs, it's one thing you don't really think about if you've done metal stud projects your whole life. Metal studs come out straight. They're pretty straight almost all the time. Wood studs do not. So if some studs get thrown into a wall, like say in the shower pocket, and you go to measure the top, you go to measure the bottom, you measured out right, but you didn't check that middle, those studs could be crowned, they could be bowed. So keeping that while you're doing your QC, making sure you've got your widths from top to bottom all the way, not just at the top and the bottom. It's important to check, because you'll go to slide in your shower base and it won't go, or you go to put your shower surrounds in and your shower surrounds bowed, or you go to put a mirror on the wall and your mirror's sticking up the wall at the bottom of 1/2 of an inch. Those are things to think about and make sure that hopefully it's rare on projects, but it's definitely things that can definitely happen. Any other Pisers anyone would like to share with wood framing?
Just in general, panelized, just make sure that the panelized guy is supplying every single interior partition. There can be, I think you talked about half walls or short walls, or some of the detail stuff that might be out of wood frame that they, oh no, that's included, that's kind of framed in afterwards. I don't know if you guys have. I think that the panelized guy is that you're stick framing in the field rather than panelizing, and you can talk to them about, hey, what makes sense to panelize and what doesn't, and then you buy the same thing with your installer.
Yeah, I would say that it's easy to buy all-inclusive drawing. Like, you're my wood, you got all the materials for this building. There's no separate contract. There's nobody else doing this work. But one thing we have run into is just if the drawings were not clear on what type of stud, what header it was, or, if there was any kind of questionable doubt of what should have been in their material list, at the end of the day, the supplier does try to go back to, well, here's the material list I sent you, which is like 15 pages of stuff that you can't even understand. So I would say your lumber supplier, while you do time to a set of drawings, it's also kind of tied to making sure the structural engineer was clear on what it was supposed to be.
Well, to piggyback off of that, if you're buying them separate, you need to make sure there's an understanding of how much loose lumber you have with the supplier and how much loose lumber your labor is using in the field, because there needs to be some communication or documentation between those two. Because a lot of times your framers will go through and just be burning through loose lumber, and then all of a sudden you're halfway through the project and you use 75% of your loose lumber, and then it's the finger pointing game. So making sure that communication happens, and you have some way of designating that with your laborer versus the supplier. So at the end of the day, we don't foot the bill for the extra material.
That makes sense. Is that something that's more prevalent with stick building, like where you've got pallets on pallets
No, I would say it's more prevalent with the panelized than when you have because you'll have a loose lumber package with your panelized product. It's just for blocking and everything like that. And a lot of times those guys will go through and just use and abuse it because they're not purchasing the lumber. So they just call call up and say, hey, I need more loose lumber out here. I need more 2x6s, send it out. And then at the end of the day, you get the bill from the supplier and you go, ah, shoot,
Yeah.
what do I do now? And trying to document that. If you document it, it's easy to back charge, no problem. But if you're not documenting that, you could run into a trick bag at the end of the project.
The hard part is the person who's most aware of it is the laborer who's picking up on the
Exactly.
sticks of the 10-foot stud that was just cut down for some blocking.
And you can figure it out when your dumpsters are leaving with a bunch of wood. You're like, it's material I bought. But yeah, I only saw it on the panelized. On the stick build,
Well, it's everything is that.
yeah,
so-
and on the stick build, you're more likely to buy that as a complete package.
Sure.
I feel like.
I guess the only other factor I'd say from an operational perspective is just inherently, even if you are doing panelized, inherently there still is field work that needs to happen, and that always seems to be like behind tit for the guy that's doing the work. He wants to do show work, throw the building up. So I would keep an eye on it, and you definitely need to, as the work's available, probably request a separate crew to get in a lift and start running around the building and doing all your miscellaneous details that need to be done, because otherwise you're gonna get to a point where you're think you're ready to start facades, and you've probably got 2 more weeks of stuff that still needs to get buttoned up before you can.
Yeah, that's understanding your framers too. How do they approach the building? Like on a stick built, they're gonna go do all the show work, and then when do they send that QC crew in that's actually fine tuning, getting blocking installed, making sure everything's square? Figuring that out in the buyout process is better than sitting there and you got everybody ready to go in there and you're still dealing with quality control issues.
Because they're going to tell you the same thing the window guy's going to tell you. They're not going to go in and shim and shave everything until the work's
Exactly.
done.
So that's learned from a contractor I'm using that used on one project, and he burned me by not sending that QC through early enough, and we were dealing with QC 40 days after they contractually were supposed to be out of the building. Whereas now in their contract, it's written when that QC crew has to start going through the building, when they need to finish a section, and it's all detailed with them. And that's just kind of learning from that process and understanding that process better with the framers.
Well, that's a really good point, though. I mean, I just argue that's probably something that everybody should have written into their stick-built subcontracts.
Yep.
That may not be something that's in the boilerplate. That's good for everybody here to know. It's on their computers.
For every sub that potentially is a piece worker.
Yes. Yeah, for anybody who you're buying piece or you're buying second and third tier labor with. That's the choice.
Go buy a $200 laser level, carry it around with you with your little tripod, set it down every so often, check them constantly. Because shit can be straight, but doesn't mean it's.
Yeah.
Don't leave it around.
Yeah.
Cool. Well, just in time. 2 minutes late. So, appreciate the time, guys.
Yeah, that's.